Welcome back for another deep dive. And this time, we're tackling something that's really important for anyone who uses data to make decisions, which is pretty much all of us these days, right?
Definitely.
We're talking about type I and type 2 errors. And they might sound kind of technical and jargony,
Yeah,
but trust me, they're super important to understand
absolutely.
if you want to make smart choices based on data.
That's right. Because these errors are like two sides of the same coin in statistics.
Okay, so to kick things off, can you guys set the stage for us?
Yeah.
What exactly are type I and type 2 errors all about?
Well, imagine you're testing out a new weight loss program. You have a group of people trying it out, and you want to know if it actually works.
Right.
Now, in statistics, we start with what's called the null hypothesis.
Uh-huh.
And that's basically the assumption that the program doesn't do anything special, no effect on weight loss.
Okay, so we're assuming it doesn't work until we see proof that it does.
Exactly. Then we have the alternative hypothesis, which is what we're trying to prove, that the program really does lead to weight loss.
Got it. So it's like a courtroom where the weight loss program is innocent until proven guilty.
Uh-huh. I like that. That's a great analogy. Now, to decide whether to declare the program guilty of actually working, we look at the data from our participants, and we use statistical tests to calculate something called a p-value.
Okay. P-values. I've heard of them, but they always seemed a bit mysterious. Can you break it down for us?
Sure, think of the p-value as a measure of how surprising our results are.
Okay.
It tells us how likely it is to see the results we got, or even more extreme results, if the program actually had no effect. So if the p-value is really low, it means we're pretty surprised.
Right. Yeah, that makes sense. So a low p-value suggests the program might actually be doing something.
Exactly. Now this is where alpha comes in.
Right.
Alpha is like a threshold for our surprise level. It's the probability of us rejecting the null hypothesis. In other words, saying the program works when it actually doesn't.
So alpha is like setting the sensitivity of our surprise meter.
Perfect analogy. And a common alpha level is 0.05, which means we're accepting a 5% chance of being wrong when we say the program works.
Okay, so that brings us to type I errors. Our surprise meter's going off, even though there's nothing to be surprised about.
Precisely. A type I error is rejecting the null hypothesis when it's actually true.
Uh-huh.
So in our example, it would be like saying the weight loss program works when it really doesn't. It's a false positive.
So if type I errors are false positives, what are type 2 errors then?
Type 2 error is the opposite.
Okay,
Failing to reject the null hypothesis when it's actually false.
got it.
It's like missing a real effect.
Wow.
So in our weight loss example, it'd be saying the program doesn't work when it actually does.
Seems like both errors could have real consequences. Which one is worse then?
That's a great question. There's no easy answer, unfortunately. It really just is on the situation
Yeah.
and the potential costs of each error.
Right.
So in some cases, a false positive might be more harmful. Like imagine a medical test that incorrectly diagnoses a disease.
Right, that could lead to unnecessary treatments and a lot of anxiety.
Exactly. But on the other hand, a false negative could be even more dangerous.
Oh, I see.
Like what if a medical test fails to detect a serious illness?
Yeah, that could be really bad if it goes untreated.
Mm-hmm.
So there's no clear winner in the which error is worse competition.
Not really. It all comes down to carefully considering the risks and benefits for each specific situation.
All right. This is making a lot more sense now. But I am curious about one more term. Power. What exactly does it mean when we talk about the power of a test?
Power is the probability of correctly rejecting the null hypothesis when it's actually false.
Okay.
In other words, it's the ability of our statistical test to find a real effect if it's really there.
So a powerful test is like a really good detective. Picks up on all the clues.
Exactly. And one of the things that really affects power is sample size.
So the more people we have in our weight loss program study, the more powerful our test is going to be.
Yes. Generally speaking, larger samples give us more power.
Got
More
it.
data means a better chance of spotting those real effects.
That makes sense.
Yeah.
But I'm guessing there are limits to how much data we can actually collect in the real world, right?
Absolutely. Getting huge amounts of data can be expensive, it can be time-consuming, or even ethically challenging in some cases. So we often have to strike a balance.
But we've got to be smart about how much data we're collecting, weighing the benefits of more data against the practical stuff, like
Yeah.
time and budget and all that.
Absolutely. It's all about finding that sweet spot. And that actually leads us to another important factor: testing duration. How long we run our study can really make a difference.
Oh, yeah. I can see how a longer study could give you more data,
Mm-hmm.
but are there any downsides to running a test for too long?
Definitely. For example, in our weight loss program, let's say people's motivation might change over time.
Right.
They could get bored, they might lose interest, or they might start doing other healthy things that weren't part of the program.
So it gets harder to tell what's really causing the weight loss.
Exactly. And then there's the external factors. Imagine our weight loss study starts right before the holidays.
Oh, yeah.
All that delicious food and all those treats, it could totally throw off the results, right?
For sure. Make the program seem less effective.
Exactly. So yeah, testing duration is kind of like a double-edged sword.
I see that.
More data, but you also got to watch out for all these other things that could mess with your conclusions.
So how do you even figure out the ideal length of time for a study? Seems tricky.
It is. There are a few key things to consider. One is the level of statistical power we want,
Okay.
the expected size of the effect, and then the characteristics of the people in the study.
So if you're looking for a small effect,
Mm-hmm.
or if you have a really small group of people, you might need to run this study longer.
Exactly. But if you're expecting a really big and obvious effect, and you've got a large group,
Okay.
you might be able to get away with a shorter study.
Got it. So no easy answers, just got to weigh all these different factors.
Yeah.
And remember those type I and type 2 errors. Got to keep those in mind the whole time.
Absolutely.
It's like a checklist, right?
Yeah.
We're not just looking at the numbers. We're thinking about all the things that could go wrong.
Exactly. We have to be aware of those false positives and those false negatives,
Right.
and how they might affect what we decide to do.
So when we're looking at the results of a study, how can we spot those errors? Can you tell?
Well, you can't always know for sure, but having a good grasp of those concepts we talked about, p-value, alpha, and power, can really help us
Got it.
to look at the data with a more critical eye.
Can you give us an example of how all that comes together in a real-world situation?
Sure. Let's say we're looking at a study about a new drug,
Okay.
and it says it's effective for a certain condition, and the study reports a p-value of 0.03.
All right, so that's below that 0.05 alpha level.
Yeah.
So the researchers are saying they found a statistically significant result.
That's right. But we also need to think about the power of that study. If the power was low, then there's a higher chance of a type 2 error.
Which meaning...
They might have missed a real effect.
Oh, I see.
So even though the p-value is low, we might still be a little skeptical if the study wasn't very powerful.
So it's kind of like being a detective. You got to look at all the clues, not just one piece of evidence.
Exactly. And that's where understanding type I and type 2 errors is so important. It helps us evaluate the evidence and make good decisions based on all the information.
So it sounds like we should always be a little bit skeptical when we're looking at data.
Yeah, exactly. I mean, we shouldn't just blindly accept every statistic or study result we see.
Right.
We got to think about those errors,
Uh-huh.
ask the right questions, and really look at the evidence before we jump to conclusions.
So it's not enough to just crunch the numbers.
Right.
We also need to understand what those numbers might be hiding or what they might not be telling us.
That's a great way to put it. And this goes way beyond just scientific research, too. We see data everywhere these days.
Oh, yeah, that's true. So how do these errors show up in our everyday lives?
Huh?
Can you give us some examples?
Sure. Think about those online quizzes that tell you your personality type.
Oh, yeah, those are fun.
Or like what career you should have.
Mm-hmm.
They seem really insightful, but a lot of them are based on really small samples, and they haven't been tested very rigorously.
Oh, I see.
So there's a good chance those quizzes could be making type I or type 2 errors.
And giving people inaccurate results.
Exactly. Or how about those news headlines that are always contradicting each other?
Oh, yeah, all the time. One week coffee's good for you and the next week it's bad.
Right. It's hard to keep up.
It really is.
But that's where understanding these statistical ideas can be so helpful. You can ask yourself, how big was that study? How long did it last? Was there anything else going on that could have skewed the results?
So we can start to think more critically about those headlines.
Yes, and that's really what this deep dive has been all about. We want you to be savvy data consumers. Whether you're reading a news article or making a decision about your health, or even evaluating a new business strategy.
Awesome. Well, I think we've covered a ton of ground today. We talked about those null and alternative hypotheses, p-values, alpha, power, sample size, testing duration.
It's been quite a journey.
It has. Yeah. And all that stuff ties back to those type I and type 2 errors.
And remember, these concepts aren't just for statisticians or data scientists or people like that. They're for everyone.
Right. Everyone uses data these days.
Exactly.
So to wrap things up, what's the one thing you want our listeners to take away from all this?
Don't be afraid to question the data you see.
Good advice.
Don't just take those numbers at face value. Dig a little deeper, ask those critical questions, and always think about those potential errors.
It's about becoming more data literate, using that knowledge to make better decisions.
That's the goal.
Fantastic. Well, thanks for joining us for this deep dive into Type I and Type 2 errors. We hope you learned a lot, and be sure to tune in next time as we keep exploring the world of data and all the ways it impacts our lives.